Hi, my name is Asma Zurishazina. This is a video for fluid mechanics. So I would like to present a simple explanation on a topic from hydrodynamics, which is principle of conservation of mass. So let's get on into the video.
Principle of conservation of mass. First of all, I want to mention this topic is related with continuity of equation and a steady flow of fluid. Before that, we must know mass of a body is constant during its motion. So let me explain through the diagram. At the inlet here, there is a volume entering big diameter and size of segment, and it's move over here and enter a smaller diameter and size of segment, and then they're leaving the outlet, but it still take up the same amount of volume here and here, even though they enter and leaving from different size of shape. So it's proof the statement here, which is for a steady flow, the mass of flow entering the segment must be equal to the mass of flow leaving the segment. Next, for further explanation of continuity equation, okay, here the formula of Q is equal to volume over time, where the volume is equal to area times length, and we can simplify to area times length per time, and length per time is equal to velocity. So from that we get the formula of Q is equal to area times velocity. And as I mentioned before, section 1 and section 2 has a same and equal of volume. So we can conclude that Q1 and Q2 is equal. So we get the equation of continuity, which is A1 V1 equal to A2 V2.
And so let's start with the continuity equation, which is simple. We've got a PHET simulation. You can see as the fluid's moving, it's moving faster on the right. And so if we use a flux meter, on the left side, the cross-sectional area is 10 meters squared, and the speed is going to be 0.5 meters per second. So that would be my A1 times my V1. If I move over to the right side, now my cross-sectional area is 1. What's my velocity? 5 meters per second. And so I can just solve for the one I don't know, and I can figure that out.
So what is the use of quantity equation? The use of quantity equation is to determine the change in velocity of fluid due to contraction and expansion of pipe diameter. Okay, to be more clear, let's move to an example. So here is an example which is given the following. What will be the velocity of water as it exits the nozzle? So he want to find the V nozzle here. Okay, given that R hydrant is 2 cm, V hydrant 4 meter per second, R nozzle 1 centimeter, and V nozzle we don't know. So how to find the V nozzle? So let's move to the problem. Okay, as given R1 is equal to 0.02 meter, R2 0.01 meter, V1 4 meter per second, and we don't know the V2. So how to find the V2? First, area is equal to pi R squared. So this is the formula of area. So we substitute the R1 here, so we get the area, and then we find the Q1 first, substitute the area and velocity given, then we get the Q1. Okay, and then same goes to the area 2. We find the area by substitute the diameter, the radius here, and we get the area 3.14, then negative 4 meters squared. So we already know the Q1. So due to the continuity equation, which is Q1 is equal to Q2. So Q1 5.04 then negative 3, we can equal to the Q2 area times V2. So we want to find the V2 here. So V2, after calculate, we get 16 meter per second.
How is it? I hope you guys can understand and more clear about conservation of mass. And thank you for watching.